the theory of relativity stands as a monumental pillar in the edifice of modern physics, forever altering our understanding of space and time. As we delve into the intricacies of this groundbreaking concept, we find that it not only revolutionized our grasp of the universe, but also profoundly impacted the trajectory of human innovation. In the late 19th century, the scientific community was abuzz with the discovery of X-rays by Wilhelm Conrad Röntgen in 1895. This breakthrough sparked a flurry of research into the nature of light and electricity, as scientists sought to understand the underlying principles that govern these phenomena. Amidst this intellectual ferment, a young Albert Einstein, then just 16 years old, was immersed in his studies at the Swiss Federal Polytechnic University. The year was 1896, and Einstein's fascination with the works of James Clerk Maxwell and Hermann Minkowski would soon set him on a path that would revolutionize our understanding of space and time. As Einstein delved deeper into the world of physics, he became increasingly intrigued by the concept of electromagnetism, which Maxwell had so eloquently described in his equations. The idea that light was not just a wave, but an electromagnetic disturbance that could propagate through the ether, sparked Einstein's curiosity about the nature of reality itself. He spent countless hours poring over the works of Sir Isaac Newton, whose laws of motion and universal gravitation had dominated the scientific landscape for centuries. Yet, Einstein began to see the limitations of Newton's theories, particularly in their inability to account for the behavior of light and other electromagnetic phenomena. In the midst of this intellectual exploration, Einstein found himself drawn to the concept of time and its relationship to space. He was particularly fascinated by the idea of simultaneity, which had been explored by the French philosopher Henri Poincaré. The question of whether two events could be considered simultaneous, regardless of the observer's frame of reference, became a central theme in Einstein's thinking. As he grappled with these complex ideas, Einstein began to formulate his own theories about the nature of space and time, laying the groundwork for what would eventually become the special theory of relativity. Meanwhile, in the world of experimental physics, scientists such as Michelson and Morley were conducting groundbreaking research on the speed of light. Their famous experiment, which attempted to measure the speed of light in different directions, yielded a surprising result. The speed of light remained constant, regardless of the observer's motion. This finding flew in the face of traditional notions of space and time, which held that the laws of physics should vary depending on the observer's frame of reference. As Einstein delved deeper into the mysteries of space and time, he found himself drawn to the works of Hendrik Lorentz, a Dutch physicist who had been exploring the concept of local time. Lorentz's theory, which proposed that time could vary depending on an object's motion relative to the observer, resonated deeply with Einstein's own thoughts on the subject. In 1899, Lorentz had introduced the concept of local time, which suggested that time was not absolute, but rather dependent on the observer's frame of reference. This idea would later become a cornerstone of Einstein's special theory of relativity. Meanwhile, in 1900, the French physicist Henri Poincaré delivered a lecture at the International Congress of Physics in Paris, where he discussed the concept of the relativity of space and time. Poincaré's words would have a profound impact on Einstein, who was deeply influenced by the French philosopher's thoughts on the nature of reality. As Einstein continued to grapple with the complexities of space and time, he began to see the universe in a new light, one where the traditional notions of absolute time and space were no longer tenable. In 1902, Einstein landed a job at the Swiss Patent Office in Bern, Switzerland, where he would spend the next 7 years evaluating patent applications related to electrical and mechanical inventions. This humble position would provide Einstein with the financial stability and intellectual freedom to pursue his true passion, theoretical physics. It was during this period that Einstein's thoughts on relativity began to take shape, as he spent countless hours pondering the mysteries of space and time. One of the key challenges that Einstein faced in his quest to develop a theory of relativity was the concept of ether, a hypothetical substance that was thought to permeate the universe and serve as a medium for the transmission of light. The existence of ether had been proposed by scientists such as James Clerk Maxwell, who believed that it was necessary to explain the propagation of electromagnetic waves. However, Einstein was skeptical of the idea, and he began to explore alternative explanations for the behavior of light. In 1904, Einstein's friend and colleague Michele Besso visited him in Bern, and the two men engaged in a heated discussion about the nature of space and time. Besso, who was an engineer and a philosopher, had been exploring the concept of relativity in his own work, and he encouraged Einstein to pursue his ideas with greater rigor and precision. This conversation would have a profound impact on Einstein, who began to see the theory of relativity as a way to unify the laws of physics and provide a deeper understanding of the universe. As Einstein's thoughts on relativity continued to evolve, he found himself increasingly drawn to the work of Max Planck, a German physicist who had been exploring the concept of quantum theory. In 1900, Planck had introduced the idea that energy is not continuous, but rather comes in discrete packets, or quanta, and this notion would later have a profound impact on Einstein's own thinking about the nature of space and time. Meanwhile, in 1904, the Hungarian physicist Loránd Eötvös was conducting experiments on the gravitational redshift of light, which would later provide important evidence for Einstein's theory of general relativity. In the spring of 1905, Einstein's friend and colleague, Marcel Grossmann, visited him in Bern, and the two men engaged in a series of intense discussions about the nature of space and time. Grossmann, who was a mathematician and a physicist, had been working on the theory of non-Euclidean geometry, and he introduced Einstein to the work of Henri Poincaré and David Hilbert, which would later play a crucial role in the development of Einstein's theory of general relativity. As Einstein delved deeper into the mysteries of space and time, he began to see the universe as a complex, interconnected web of relationships, rather than a collection of separate, independent objects. In May 1905, Einstein wrote a letter to his friend and colleague Conrad Habich, in which he outlined his latest thoughts on the theory of relativity. In this letter, Einstein described his idea of relativity as a way of understanding the universe that was based on the principle of covariance, or the idea that the laws of physics should be the same for all observers regardless of their relative motion. This concept would later become a cornerstone of Einstein's special theory of relativity, and it marked an important turning point in his thinking about the nature of space and time. As the summer of 1905 approached, Einstein's thoughts on relativity were beginning to take shape, and he was poised to make a major breakthrough. In June 1905, he submitted a paper to the journal Annalen der Physik, in which he outlined his theory of special relativity. This paper, which was titled On the Electrodynamics of Moving Bodies, introduced the concept of time dilation and length contraction, and it challenged the traditional notions of absolute time and space that had been accepted for centuries. In the months that followed, Einstein's paper on special relativity sparked a lively debate among physicists about the nature of space and time. One of the key critics of Einstein's theory was the German physicist Max Abraham, who argued that the theory was incompatible with the principles of classical mechanics. However, Einstein was undeterred by these criticisms, and he continued to develop his ideas about relativity, driven by a deep conviction that the universe was a simpler and more elegant place than most people realized. As the year 1905 drew to a close, Einstein's theory of special relativity had already begun to attract attention from physicists around the world. In December 1905, the German physicist Max Planck wrote a letter to Einstein, in which he praised his theory as a masterpiece and encouraged him to continue developing his ideas about the nature of space and time. This letter marked an important turning point in Einstein's career, as it helped to establish him as a major figure in the world of physics, and it paved the way for his future work on the theory of general relativity. In the early months of 1906, Einstein continued to refine his theory of special relativity, and he began to explore its implications for our understanding of the universe. He wrote a series of papers on the subject, including one that introduced the concept of relativistic mass, which showed that the mass of an object increases as it approaches the speed of light. This idea was a direct consequence of Einstein's theory of special relativity, and it helped to further establish his reputation as a leading figure in the world of physics. As Einstein's reputation grew, he began to receive invitations to speak at conferences and universities across Europe. In 1907, he was invited to give a lecture on his theory of special relativity at the University of Zurich, where he met with the renowned physicist Alfred Kleiner. Kleiner, who was impressed by Einstein's work, offered him a position as a lecturer at the university, which Einstein accepted. This marked the beginning of Einstein's academic career, and he quickly became known for his charismatic teaching style and ability to explain complex concepts in simple terms. In 1908, Einstein's theory of special relativity received a significant boost when the German physicist Max Planck used it to explain the behavior of black-body radiation. Planck's work provided strong evidence for the validity of Einstein's theory, and it helped to establish him as a leading figure in the world of physics. Einstein's theory also caught the attention of the famous mathematician David Hilbert, who was working on a similar theory of relativity at the time. Hilbert and Einstein began to exchange letters, and their correspondence played an important role in the development of Einstein's theory of general relativity. In 1909, Einstein was appointed as a professor of theoretical physics at the University of Zurich, where he continued to work on his theory of relativity. He also began to explore the implications of his theory for our understanding of gravity and space-time. Einstein's work during this period was influenced by the ideas of the mathematician Marcel Grossmann, who introduced him to the concept of non-Euclidean geometry. This concept played a crucial role in the development of Einstein's theory of general relativity, which he would complete several years later. In 1910, Einstein's theory of special relativity received further confirmation when the American physicist Robert Millikan conducted an experiment that verified the existence of time dilation. Millikan's experiment involved measuring the time it took for a clock to tick at different speeds, and his results were in agreement with Einstein's predictions. This experiment provided strong evidence for the validity of Einstein's theory, and it helped to establish him as one of the leading physicists of his time. In 1911, Einstein was invited to attend the Solvay conference in Brussels, where he met with some of the most prominent physicists of the day, including Max Planck, Marie Curie, and Ernest Rutherford. The conference was a major event in the world of physics, and it provided Einstein with an opportunity to discuss his theory of relativity with other leading experts in the field. During the conference, Einstein presented a paper on his theory of special relativity, which sparked a lively debate among the attendees. In 1912, Einstein returned to Prague, where he had accepted a position as a professor of theoretical physics at the German university. It was during this period that he began to work intensively on his theory of general relativity, which would eventually revolutionize our understanding of gravity and space-time. Einstein's work on general relativity was influenced by the ideas of the mathematician Élie Cartan, who introduced him to the concept of differential geometry. In 1913, Einstein's theory of special relativity received further confirmation when the British physicist Ernest Rutherford conducted an experiment that verified the existence of length contraction. Rutherford's experiment involved measuring the length of a rod at different speeds, and his results were in agreement with Einstein's predictions. In 1914, Einstein's work on general relativity was further influenced by his correspondence with the mathematician David Hilbert. The two men engaged in a lively exchange of ideas, with Hilbert sharing his own work on the subject and Einstein providing feedback and insights. This collaboration played a significant role in shaping Einstein's theory, particularly in regards to the mathematical framework that underpinned it. Meanwhile, the outbreak of World War I had a profound impact on the scientific community, with many researchers being drafted into military service or redirected towards war-related research. Despite these challenges, Einstein continued to work tirelessly on his theory, driven by his conviction that it held the key to unlocking the secrets of the universe. In 1915, Einstein's efforts finally came to fruition when he presented his complete theory of general relativity to the Prussian Academy of Sciences. The theory was a masterpiece of mathematical elegance and physical insight, providing a radical new perspective on the nature of gravity and space-time. At its heart was the concept of curvature, which posited that massive objects such as stars and planets warp the fabric of space-time around them, giving rise to the phenomenon we experience as gravity. The theory also predicted a range of novel effects, including gravitational redshift, gravitational lensing, and frame dragging, which would later be confirmed by experiment and observation. The reception of Einstein's theory was initially mixed, with some physicists hailing it as a revolutionary breakthrough, while others expressed skepticism or even outright hostility. One notable critic was the physicist Philip Lenard, who argued that Einstein's theory was too mathematical and lacked empirical support. Despite such criticisms, Einstein remained confident in the validity of his theory, knowing that it had been carefully crafted to account for a wide range of phenomena and observations. As the years passed, the evidence in favor of general relativity continued to accumulate, with observations of gravitational redshift, bending of light around massive objects, and the precession of Mercury's orbit all confirming key predictions of the theory. In 1916, Einstein's theory received a significant boost when the astronomer Carl Schwarzschild used it to predict the existence of black holes. Schwarzschild's work showed that according to general relativity, a star that was sufficiently massive and compact would warp spacetime around it so severely that not even light could escape, giving rise to a region known as the event horizon. This prediction was a radical one, challenging conventional notions of space and time, and it sparked a lively debate among physicists and astronomers about the implications of general relativity for our understanding of the cosmos. In 1917, Einstein's work on general relativity took a new turn when he began to explore its implications for cosmology. He realized that his theory predicted that the universe as a whole was dynamic and evolving, with matter and energy being constantly redistributed throughout spacetime. This idea challenged the traditional view of the universe as a static, unchanging expanse, and it sparked a new wave of interest in cosmological research. Einstein's own work on cosmology was influenced by his correspondence with the astronomer Willem de Sitter, who shared his observations of galaxy distributions and the large-scale structure of the universe. In 1918, Einstein's work on cosmology led him to correspond with the German astronomer Erwin Freundlich, who was attempting to test the predictions of general relativity through observations of the solar eclipse. Freundlich's efforts were hindered by the ongoing war, but he eventually managed to secure funding for an expedition to Crimea, where he hoped to measure the bending of starlight around the sun during a total solar eclipse. Although the expedition was ultimately unsuccessful due to bad weather, Einstein's interactions with Freundlich helped to further solidify his ideas about the role of gravity in shaping the universe. Meanwhile, the British astronomer Arthur Eddington had become increasingly interested in Einstein's theory and its potential implications for our understanding of the cosmos. In 1919, Eddington led an expedition to the island of Principe off the coast of West Africa, where he aimed to measure the bending of starlight during a total solar eclipse. The results of this experiment would provide crucial evidence for or against Einstein's theory, and Eddington was determined to get it right. On May 29, 1919, Eddington and his team observed the eclipse and made meticulous measurements of the star positions near the sun. The data they collected would take months to analyze, but eventually it would provide conclusive evidence for the validity of general relativity. As news of Eddington's experiment spread, Einstein's theory began to gain more widespread attention and acceptance within the scientific community. In 1920, the Dutch physicist Hendrik Lorentz invited Einstein to give a series of lectures at the University of Leiden, where he could share his ideas with a broader audience. Einstein's lectures were a huge success, and they helped to establish him as one of the leading figures in modern physics. During his time in Leiden, Einstein also had the opportunity to engage in discussions with other prominent physicists, including Niels Bohr and Paul Ehrenfest, who would go on to play important roles in the development of quantum mechanics. In 1921, Einstein embarked on a major tour of the United States, where he gave lectures at several prominent universities, including Princeton and Harvard. His visit was widely publicized, and it helped to cement his status as an international celebrity. During his time in America, Einstein also met with influential figures such as Thomas Edison and Henry Ford, who were eager to learn more about his revolutionary ideas. Although Einstein's theory of general relativity was still a topic of debate among physicists, his charisma and persuasive abilities had won over many skeptics, and he was now widely regarded as one of the most brilliant minds of the 20th century. As Einstein's fame continued to grow, he began to receive numerous invitations to speak at conferences and symposia around the world. In 1922, He attended the International Physics Conference in Paris, where he engaged in lively debates with other prominent physicists, including Marie Curie and Ernest Rutherford. The conference was a major success, and it marked an important milestone in the development of modern physics. During his time in Paris, Einstein also had the opportunity to visit the laboratory of Jean Perrin, who had recently made groundbreaking measurements of the Avogadro constant using a technique known as ultracentrifugation. In 1923, Einstein's travels took him to Japan, where he was greeted with great enthusiasm by the scientific community. He spent several weeks lecturing at various universities, including the University of Tokyo, where he met with prominent physicists such as Satyendra Nath Bose. During his time in Japan, Einstein also had the opportunity to engage with the country's rich cultural heritage, visiting temples and gardens, and even composing music on the shamisen, a traditional Japanese instrument. Upon his return to Europe, Einstein became increasingly involved in international efforts to promote peace and understanding. In 1924, he joined the International Committee on Intellectual Cooperation, a precursor to UNESCO, where he worked alongside other prominent intellectuals such as Marie Curie and Henri Bergson. Einstein's commitment to pacifism and social justice also led him to become a vocal critic of nationalism and militarism, as evidenced by his public statements and writings during this period. The mid-1920s saw significant advances in the development of quantum mechanics, with key contributions from physicists such as Werner Heisenberg, Erwin Schrödinger, and Niels Bohr. Einstein's own work on the theory of relativity continued to influence these developments, although he himself remained skeptical about the fundamental principles of quantum mechanics. In 1925, Einstein engaged in a series of debates with Niels Bohr at the Solvay Conference in Brussels, where they discussed the implications of quantum mechanics for our understanding of space and time. In the late 1920s, Einstein's health began to decline, and he suffered from a series of ailments, including stomach problems and fatigue. Despite these challenges, he continued to work tirelessly on his unified field theory, seeking to integrate gravity, electromagnetism, and quantum mechanics into a single, coherent framework. In 1928, Einstein published a paper outlining his latest thoughts on the subject, although the work ultimately proved to be incomplete and unsatisfactory. The year 1929 marked a significant turning point in Einstein's life as he began to receive increased attention from the media and the general public. His 50th birthday was celebrated with great fanfare, and he was hailed as one of the most important scientists of the century. Einstein's response to this attention was characteristically humble and self-effacing, although he did use the opportunity to speak out on issues of social justice and human rights. In the early 1930s, Einstein's concerns about the rise of nationalism and militarism in Europe led him to become increasingly vocal about the need for international cooperation and disarmament. In 1932, he joined the League of Nations Committee on Intellectual Cooperation, where he worked alongside other prominent intellectuals to promote peace and understanding. However, as the political situation in Europe continued to deteriorate, Einstein's own position became increasingly precarious, particularly given his Jewish heritage and his outspoken criticism of nationalism. In 1933, following Adolf Hitler's rise to power in Germany, Einstein's home in Katowice was raided by the Nazi authorities and his property was confiscated. Einstein himself was in the United States at the time, where he had been visiting Caltech and lecturing on his unified field theory. He never returned to Germany, instead choosing to settle in the United States, where he would remain for the rest of his life. Einstein's decision to immigrate to the United States marked a significant turning point in his life and career. He was appointed as a professor of theoretical physics at Princeton University, where he would work alongside other prominent physicists, including John Wheeler and Nathan Rosen. Over the next several decades, Einstein continued to work on his unified field theory, although he also became increasingly involved in public life, speaking out on issues such as civil rights, nuclear disarmament, and the responsibilities of scientists in society. Throughout the 1940s and 1950s, Einstein's fame continued to grow, and he became one of the most recognizable figures of the 20th century. He was awarded numerous honors and accolades, including the Copley Medal and the Max Planck Medal, and he was even offered the presidency of Israel, which he declined. Despite his advanced age and declining health, Einstein remained committed to his work and his principles, continuing to inspire generations of scientists, philosophers, and thinkers around the world. In the final years of his life, Einstein's work on the theory of relativity continued to influence developments in physics, from the discovery of gravitational waves to the exploration of black holes. His legacy extended far beyond the scientific community, however, as he became a cultural icon and a symbol of intellectual curiosity and creativity. As news of his death on April 18, 1955, spread around the world, tributes poured in from leaders, scientists, and ordinary people, all of whom recognized the profound impact that Einstein had had on our understanding of the universe and our place within it. Its impact extends far beyond the realm of physics, influencing art, philosophy, and culture, and inspiring generations to question, seek, and explore. Thank you for joining me throughout this historical journey. That's all for today's History with Herodotus. Remember to like, share, and subscribe, and until next time, remember that, to understand the present, we must first understand the past.